Welcome to our video tutorial on Solidity. In this video, we will be diving into the advanced concepts of Solidity contracts. Let's get started. Solidity contracts are like a class in any other object-oriented programming language. This means the similarity between Solidity contracts and the classes in other object-oriented programming languages. Contracts in Solidity serve as a blueprint for creating objects or instances that can hold data and define functions. They firmly contain data as state variables and functions which can modify these variables. This means contracts in Solidity consist of two main components: state variables and functions. State variables are used to store data or the state of the contracts, and functions are responsible for modifying these variables. Think of state variables as the contract's internal memory and the functions as the operations or behaviors that can change or interact with this memory. When a function is called on a different instance, the Ethereum virtual machine function call happens and the context is switched in such a way that the state variables are inaccessible. This means when a function is invoked on a specific contract instance, a function call occurs in the Ethereum virtual machine. During this process, the context switches to the specific contract instance being called, and the state variable associated with that instance become accessible within the function. In other words, the function can access and modify the state variables of the contract it's called on. A contract or its function needs to be called for anything to happen. This means in Solidity, contracts and their functions are not automatically executed or triggered. To initiate any action or change in the contract's state, you need to explicitly call the contract or its functions. This means that the execution of the contract's logic depends on external interactions, such as a user or another contract invoking the functions defined within the contract. Let's talk about some basic properties of contracts. First, we have a constructor. Actually, the constructor is a special method created using constructor keyword in Solidity. So it's invoked only once when the contract is created, typically during deployment. The constructor allows you to initialize the state of the contract, set initial values for state variables, and also perform any necessary setup or configuration. So it's important to note that the constructor has the same name as the contract itself and is optional, okay? Once the constructor is executed during contract creation, its code is not executed again, okay? Next, we have state variables. State variables are variables that are used to store and maintain the state of the contract. So they represent the contract's internal data or information that can be accessed and modified by the contract's functions. State variables actually can hold various types of data, such as numbers, strings, addresses, or custom-defined structs. These variables retain their values across different function calls and transactions, allowing the contract to preserve and update its state over time. The third one here, we have functions. Actually, functions in Solidity are used to define the behavior or the operations of the contract. They allow you to perform actions, manipulate data, and interact with the contract's state variables. Functions can be called by external entities, such as a user or other contracts, to execute specific tasks or access information from the contract. Within function, you can modify the state variables and you can perform computations, make conditional statements, and even call other functions. By modifying the state variables within functions, you can effectively change the state of the contracts over time, reflecting the desired behavior and functionality of your smart contract. So in summary here, the constructor is a special method executing once during contract creation for initialization purposes. State variables store the contract's state or internal data, while functions defines the behavior and allow manipulation of the state variables to achieve desired functionality in the contract. Now let's talk about creating contract programmatically, okay? Contracts are typically created using JavaScript API, okay, web3.js, which provides built-in function. Okay, when a contract is created, its constructor is executed, and the final code of the contract is added to the blockchain. Look at this example. In this example, the contract test, here we have contract test. Contract test is created to demonstrate how to create contract on Solidity. So this code represents a simple Solidity contract named test. Here we have a string str. This line declares a state variable called str of type string. So this is the variable, and this is the type of this variable, which is a string. State variables are used to store and maintain the state of the contract. In this case, the str variable will hold the string value, okay? About the constructor, this line, constructor function here of the contract, it accepts a string parameter called strn, okay, and initializes the state variable str with the value passed to the constructor. So this is the initialization here, okay? The memory keyword, here we add memory. The memory keyword here indicates that the string parameter is stored in memory, which is the temporary storage used during function execution. About the str, this one equal strn, this line assigns the value of the constructor parameter. So strn to the state variable str, it sets the initial value of str during contract creations. About the function str out here, this is a public function named str out. It is defined with the view visibility, and we will talk about it. View visibility modifier, which means it doesn't modify the contract state, and the function returns a string value. Return string value. So return string value here, this line simply returns the value of the state variable str when str out function is called. It allows external entities or other contracts actually to retrieve the value of str without modifying the contract state. So this contract or the contract test here has a state variable str of type string, constructor that initializes str with a value passed as a parameter, and the function str out returns the value of str. This contract allows you to set an initial string value during contract creation and retrieve the value using the str out function. We can see here the decode output. We can go to the remix. Here we have the code. When compile it, we got this is the correct code. Then we go to the deploy. Before deploy, we should add the input here. if I write here hello, okay, sorry, hello world, and deploy it, then go to str out, we have here the input hello world, and sign it. Also, we can see here the decode output string hello world. So this is the code of str or contract tests. Okay. Now let's go to the Solidity visibility modifiers. Solidity provide modifiers for functions and the state variables, which determine their accessibility. And this topic is important. There are 4 types of visibility modifiers: external, public, internal, and private. About the external functions can only be called by other contracts via transactions. They cannot be called internally within the same contract. So to call an external function from within the contract itself, we need to use this like this. We need to use this keyword followed by the function name, as you see here. Okay. So external functions are commonly used when you want to allow other contracts to interact with a specific functionality of your contract. They can be more efficient for large arrays of data, as they avoid copying the data when called externally. About the public here, public functions or variables can be accessed both externally by other contracts or accounts and internally within the contract itself. They can be called via messages, which means they can be invoked by external entities or other contracts to perform certain operations or retrieve information. Also, in Solidity, if a state variable is declared as a public and static, a getter method is automatically created, allowing external entities to read its value. Okay. What about the internal? Internal functions or variables can only be accessed internally, meaning they can only be called within the contract or its derived contract. Okay, they are not accessible to external contracts or accounts. So internal function are useful when you want to restrict certain functionality to be used only within the contract or its derived contracts. Okay, about the private functions or variables, private functions or variables are most restricted in terms of visibility. So they can only be accessed within the contract in which they are defined. Okay, private functions and variables are not visible to derived contracts, meaning they cannot be accessed or inherited by contracts that inherit from the original contract. Okay. Private visibility is often used to encapsulate and hide implementation details within the contract, so ensuring they are not accessible or tempered with externally. So to sum up, external function can be called by other contracts. Public function can be called both externally and internally. Internal function can only be called internally, and the private functions are only visible within the contract they are defined in. Each visibility modifier provides a different level of access control and helps enforce the desired behavior and security of the contract. Thank you for watching and see you in the next video.